we're going to prove these identities. So here's an identity. It says that sine of theta times cosine of theta times tangent of theta plus cosine square of theta just has to equal 1. We have to prove that that's true. My strategy is to always pick the more complicated side, which hopefully is obviously this side, the left side, and we're going to see if we can turn it into 1. If we can just take this and turn it into 1, then we know it equals 1. So let's just copy down this left side. And then while we're copying it, let's think about what strategies we have to do this. So first off, we can look for any just straight up identities that we have. I see cosine square of theta. That makes me think of Pythagorean identity, especially in relationship to 1. I also notice that there's a cosine in this first giant multiplication piece. There's also cosine here, so maybe I can factor out a cosine. But actually, I don't want to pull out a cosine just because of what I noticed in the first place, that this cosine square is kind of nice. I'm going to leave that alone. I like it to see if I can make it equal 1. So let's actually focus on this first piece. What could I do to that? Another main strategy is to turn everything into sines and cosines. This is mostly sines and cosines except for tangent. So what I'm going to do is I'm going to leave the sine alone and leave the cosine alone, but I'm going to turn this tangent into a sine over cosine. We should have that memorized, but if you forgot, it's right here. That tangent is equal to sine over cosine. Plus, we have this piece that we left alone. Again, our goal is to turn this into 1. Now, the next thing I see is technically I'm multiplying all these things, this first big term here. And this is just cosine over 1. In fact, this is also sine over 1. But I notice I got a cosine on top, cosine on bottom. That just simplifies. So this first mess of multiplication really just simplifies, and it turns into sine of theta times what remains here from our tangent that we ripped apart. And then now I just have it equal to cosine, or not equal to, but added with cosine square of theta. Now this, again, let's keep working with this. That's just sine times sine, which is sine square of theta, plus the cosine square of theta. And that should sound familiar. That's what I kind of noticed at the beginning was this cosine square. It reminds me of Pythagorean identity. Well, what we have right here is straight up the Pythagorean identity. It's this identity right here. And we know that that equals 1. So I can just say that this becomes 1. And there we've done it. We took this left side and we turned it into the right side. So we have verified that the identity is true. So I put a little check mark there to say, yep, it's true. I checked it. It's legit. Let's check out another identity to verify. This one looks a little more complicated. It's a fraction. So let's see what we can do. Let's use the strategy again. I'm going to pick the more complicated side. And to me, it's still, hopefully, clearly the left side. Fractions are a little more complicated. There's actually a lot of things we can do with fractions. We have a lot of fraction skills. So let's do some stuff with that fraction. And our goal is to turn this fraction into a sine square of theta. All right, so first let me just copy down the left side because that's what I'm focusing on. I'm going to kind of ignore the right side. Just keep it in mind for the future because we want to turn it into that right side. All right. Next thing I notice again is I got a whole lot of non-sines and cosines. I do have a sine on the top, so that's great, but everything else I can maybe change into sine and cosine. One thing I want to point out is I actually need to focus on things in a separate way. Like let's just focus just on the top, and then later we'll focus just on the bottom, kind of for each step. So let me actually draw one giant fraction, and let's just focus just on the top. So that top, that numerator, let's turn everything into sines and cosines. So that would actually be, the secant is what? That's 1 over cosine. It's the reciprocal of cosine, and that identity is right here. It's actually the alternate version. Secant is the flip of cosine, so cosine is the flip of secant. And then, let's see. Well, we already have just a plain old sine. You know what? I'm actually going to write it over 1. Since I got a fraction here now and a fraction here, I can put those together on our giant fraction that we have. In fact, let me color this giant fraction bar purple, just like what I'm going to do now. Oh, that's my giant fraction. Now, we did the top of this giant fraction. Now let's focus just on the bottom of this giant fraction. So this will be the new denominator. What I have here is a tangent plus a cotangent. Let's turn each of those into sines and cosines. Tangent is just sine over cosine, and we're adding that with cotangent, which is actually just kind of the flip, the reciprocal. In fact, it says it right here. It's cosine over sine. So it's sort of the reciprocal way. flipped around way. All right, there we go. Now we've changed the top of this giant fraction and the bottom of this giant fraction. So let's look back at the top of this giant fraction. So let me make my giant fraction line. In fact, let's scoot this up so we got a little more room here. All right, going back to the numerator of this, the top of this giant fraction. It's just a fraction times a fraction, and to multiply, you just go top times top, bottom times bottom. So that's just going to turn into sine over cosine. That's not too bad. All right, let's leave that alone. Now let's focus on the denominator here. This denominator, this giant denominator on our giant fraction, is actually a fraction plus a fraction. All right, well, how do we add two fractions? That takes a little more work. We actually need a common denominator. What I'm going to do is I'm going to erase these parentheses here, or at least move them farther away, because I need more space. I got to make a common denominator there. So this has a cosine, this has a sine. They're not alike at all. This one needs a sine. So let's actually multiply top and bottom by a sine of theta. There, now it has a sine on the denominator of it, just like that one does. But now this guy needs a cosine, so let's multiply top and bottom by cosine of theta. Now, this whole mess down here, we can do a fraction plus a fraction. They actually have a common denominator. Like, let me rewrite all that here. This giant mess, this giant denominator on my giant fraction. There we go. Okay, what do I have here now? That's just sine times sine. Wait a minute. That's just sine square of theta over our common denominator of sine of theta cosine of theta. All right. Plus this other fraction that we're going to add with is actually a cosine square of theta, cosine times cosine, and then over the common denominator, sine of theta and cosine of theta. Now I'm actually able to add these two fractions. So let's move over here. Let's go this way to try and add our fractions. So actually, let me make the giant fraction. And you know what? Let me just copy down the top. We haven't really messed with the top in a while. It's just a sine over cosine. That's for our giant fraction. And then now let's continue with the denominator down here, this giant fraction. Common denominator, so I can add them together. In fact, when I add them together, it's called a common denominator because even the answer to this addition problem is going to have the same denominator. It's just going to be a sine of theta. No, oops, not plus. It's just sine times cosine. There we go. But the top is actually what I'm adding. I got to do top plus the top. And so it's just sine square of theta plus cosine square of theta. There we go. Now wait a minute, hold on. Sine square of theta plus cosine square of theta, that is the famous Pythagorean identity. So I can rewrite this in another way with just a giant 1 right there. Okay, so let's take our whole big old mess here and let's rewrite it actually. We got the numerator is just the plain old sine over cosine. Again, we haven't messed with that in a while. But now this messy denominator is getting better and better. This messy denominator is now 1 over the sine cosine. That's because this was Pythagorean identity. It just turns into 1. All right, it's looking pretty nice. Now, look what I got here. The top of this is just a fraction, and we're going to divide it by another thing that's just a fraction. How do we do a fraction divided by a fraction? Well, we don't really do division. What we do is we turn it into multiplication. We keep it, change it, flip it. So what I'm going to do is I'm going to keep this top fraction, I'm going to keep it normal, and that's just a sine over cosine. Again, we haven't messed with that guy much. We've left him alone. But now, instead of dividing by this other fraction, we're going to multiply by the reciprocal of it. So I just need to flip that, keep it, change it, flip it. Now it's going to be sine and cosine on top, and we'll put the 1 on bottom. Now, how do you multiply two fractions? Just top times top and bottom times bottom. Or you might even notice when I do this, when I do top times top, I'm just going to have a sine on top, multiply with another sine on top, and then the cosine on top. And then the bottom times bottom, it's just going to be cosine times 1. That's just cosine. So all of this stays on top, and then all of this stays on bottom. And of course, now we notice, wait, cosine on top, cosine on bottom, cancel. We could have even canceled them right here if you're comfortable with that. And all that's left is a sine times sine. And sine times sine is just sine square. And that's actually what we wanted to turn it into. We took this crazy left side and turned it into the right side. So since we can turn it into a sine square, check, we know that we've proven the identity. We've verified it.